Alright, we're going to finish up tonight with a short lecture on the endocrine pancreas. Bear with me for this one and the clicking noise you'll hear because my Surface Pen is out of batteries and I don't feel like getting some more right now. So the endocrine pancreas, you will learn so much more than you ever thought you could about something like diabetes and insulin in med school. So I don't need to spend a whole lot of time on it, but I can give you a heads up about some high yield information. Hopefully you already know about insulin and glucagon from undergrad and stuff like that. Obviously, they are opposing hormones. And this is going to be okay. Here we go. Okay, insulin. First of all, something really important to know is that it's synthesized and secreted in the beta islet cells. Remember, the islets of the Langerhans in the pancreas has the alpha cells, beta cells. The alpha cells produce glucagon, the beta cells produce insulin, and then the other cells produce somatostatin, I think. But when it's secreted after being synthesized, it will be secreted along with C-peptide, and that's important for determining if somebody has hypoglycemia. You can determine if they have been taking exogenous insulin, like shooting up insulin when they're not supposed to. Maybe taking advantage of the anabolic effect. But anyway, if they're doing that, you'll run the labs and you'll see super high insulin and low C-peptide. So that means it's not an endogenous source. So that's why that's important. Okay, as I said, insulin's anabolic. It's the major anabolic hormone of the body. And just remembering this helped me think through a lot of test questions because if something's anabolic, it's going to be, building fat. And protein. It's going to be all about storage of energy and breaking down glucose from a meal into its components, right? Using it for energy. Insulin causes potassium to go into the cell, so that's that mnemonic for to remember its effect on potassium. And obviously you just ate a big meal, your blood glucose is super high, then insulin responds to the high blood glucose, and it travels around the body to its target tissues, and it can act at insulin dependent tissues or insulin independent tissues. That's why GLUT4 is really important to know, because GLUT4 is present on skeletal muscle and adipose tissue. That's really important to remember, skeletal muscle and adipose tissue. And those are insulin dependent tissues, which means, in order for those cells to get glucose, they need insulin. They are dependent on insulin. All right, I'm going to introduce this concept of counter-regulatory hormones. Always keep in mind, that insulin is opposed by at least these four big guys here: glucagon, growth hormone, cortisol, epinephrine. And they all cross, there's a huge crosstalk between these hormones. For instance, in times of stress, and this is really important for people with type 1 diabetes, epinephrine and cortisol are released in times of stress, and epinephrine actually stimulates the further release of glucagon. And there's a lot of crosstalk even both ways. Something I always thought was weird is, well, I guess it's not that weird, but glucagon actually stimulates the release of insulin. Anyway, just remember opposing effects. Insulin's anabolic, and it's going to be doing all the glycolysis, lipogenesis, stuff like that. And then because you know these four are opposite, glucagon has to be more catabolic, right? Like breaking down muscles for amino acids. Lipolysis, right? Breaking down fat to send free fatty acids to the liver for gluconeogenesis. See, I think I covered. Okay. All right. Quick word on diabetes. This is diabetes mellitus, right? Not diabetes insipidus. Type 1 diabetes you'll classically see in children, and it's actually an autoimmune phenomenon, and we don't really know what is the trigger. That could be anything. It could be a viral illness. It could be pretty much anything. It's actually pretty interesting when you start to read some theories on what precipitates this hypersensitivity reaction. But regardless, you end up getting an autoimmune destruction of the beta cells of the pancreas. So there's, it's a T cell mediated, right? Type 4 hypersensitivity. You'll see a bunch of lymphocytes infiltrate the beta cells, and you'll see like basically complete destruction on histology. Obviously, one of the potentially deadly situations is DKA. Hopefully, you've heard of this before. And what else about type 1 diabetes? You'll talk all about it. Something that I was kind of surprised about is both type 1 and type 2 have a genetic component, a hereditary component. But type 2 actually has a much stronger familial disposition, which is really strange, and maybe speaks to the power of epigenetics, where if you make certain lifestyle choices and develop diabetes, then from a sedentary lifestyle or whatever, then you can actually pass that on to your kids. And before med school, I had no idea that type 2 diabetes had a stronger genetic / hereditary component than type 1. So that's kind of interesting. And you will see test questions about that too. So the pathophysiology of type 2 diabetes, it's a really good example of what I talked about at the beginning of this system, this idea of receptor downregulation. What happens is in obese individuals, they develop what's called end organ resistance, EOR, we'll say that, end organ resistance, peripheral insulin resistance. And that's because the insulin receptors, remember, do you remember what kind of receptors they are? RTKs, right? Receptor tyrosine kinases. Over time, there's downregulation of these receptors, and then insulin, no matter how much insulin is produced, it can't have its effect at the tissues because of this receptor downregulation. And so what you have eventually is beta cell exhaustion. And the beta cells eventually get worn out. And if type 2 diabetes gets bad enough to its end stage, these people are completely insulin dependent for the rest of their life, just like the type 1 diabetic patients are. You can initially control type 2 diabetes without insulin, and you can actually prevent the progression of it if you make some lifestyle choices. and stuff like that. Gestational diabetes is probably, I'll put a little star here, it's probably more important maybe from a physiology perspective because it's a good teaching tool, and I'll explain in a second. So gestational diabetes is exactly what it sounds like. It's a mom who gets pregnant and develops diabetes. Okay, this is not somebody that had diabetes before they got pregnant. That would just be somebody with, type 2 diabetes, right? Or type 1. But gestational diabetes is the development of a hyperglycemic state during pregnancy. And what happens is the high blood glucose is floating around in the mother's blood, and it travels across the placenta to the baby, right? And the what's it called? Anyway, at this point in gestation, the baby has a functional pancreas. So what happens is it starts producing its own insulin because insulin is stimulated by high glucose. So insulin, remember, is a major anabolic hormone. So these babies are born with what's called macrosomia, and some of the biggest babies you'll ever see will be from mothers that had gestational diabetes. And another tie-in here is when they're born, you have to keep an eye on them because they can be predisposed to a severe hypoglycemic attack. And that kind of makes sense if you think about it, because it's producing all this insulin to deal with the source of glucose from the mother. All of a sudden it's born, it's still producing the insulin, right? But the glucose source is taken away. So the excess insulin causes rapid uptake of glucose into cells, which means the glucose is getting a lot lower in the blood, right? Hence you get hypoglycemia, and that's why you got to keep an eye on these babies. It's a good comparison table. Something that was frustrating in endocrine is there's like so many things that could stimulate the secretion or release of so many different things. So a lot of them are intuitive, though. If we have a lot of these substances floating around, right, amino acids, fatty acids, then we want to do something with them, right? We want to build anabolically. We want to build muscle. We want to build fat. On the other hand, we can kind of flip that perspective for catabolic hormones like glucagon. What else do I want to talk about? Remember the 4 counter-regulatory hormones. I'll probably ask something about that. Theoretically, any 4 of them could be diabetogenic, right? They could cause diabetes, cause a hyperglycemic state. Okay, I think that's all I want to talk about. You'll get so much diabetes in med school. It's too much.